So this is rates of change, and rates of change is pretty much what calculus is all about. Now, when you're talking about rate of change, you're talking about how one thing is related to the other. That's why, especially if you're doing physics, you'll know this really well. That's a difference of y over a difference of x. So one of the things that we would have done, I'm just going to keep using the physics example. One of the things you would have done in physics would have been, say, velocity. What's the definition of velocity? Change in what over change in what? There you go, displacement over change in time. Okay, so that would be an example of a rate of change. A rate of change is anything that's a change of something compared to another. Usually this bottom bit is either time or it's by length. They're the usual ones. So using the notation, what we need to do is we need to write out the variables, and we need to also write down the change between both. So firstly, let's define what this triangle thing is. This triangle thing means change or difference. Now, what we then need to do is we need to set out each of the variables, write out the change, then we can write out the actual rate. So, this first question, for example, the area of an oil slick A increases at a rate of 5 square meters per minute. So what we need to do is we need to write out the two variables, which is A, and this is per minute, which means it's by time. So let's write out the notation first. It's going to be change of the area over the change in time. Now this says it's increasing right here, so let's just use a plus, and then it says 5 square meters, so meters squared, per minute, like so. If it decreases, then we need to make sure that we put a negative in. So we have, in this case, the temperature, which is a capital T. Be careful, capital T is different to a small t. And this is by time, so we'll use a small t. So same thing, change in temperature over the change in time. Now this says decreases, so put a negative, and then 20 degrees Celsius per hour. So just a really quick one, I'm hoping you know this by now. A rate of change is the same as you finding the gradient. So if you're told that you need to find a rate of change based on two different things that you know, you would use the gradient formula. So remember, if it's positive, it goes to the, when you head to the right, it goes up. Negative, when you head to the right, it goes down. Faster rate means it goes up quicker, slower rate means it goes slower, I guess.